Uh-huh.
How come on the grade book it only shows like our like mine? My grade is only for my test, like my overall grade, but then we have quizzes and then the teacher.
I think it's probably because I haven't put the numbers in for the other things.
Oh.
But as a general point of order, I would never really trust the Canvas average because I don't think it's usually meaningful. Especially not in my course. For other reasons. Okay, so, excuse me. Let me begin with a word of prayer. So, Heavenly Father, we thank you for this day. Again, I thank you for these students. Just ask you to bless our time to study your creation, help us to understand a little bit more math together, and just help the students to ask good questions as they have them, Lord. In your name I pray, Lord Jesus. Amen. Okay, so let us dive into rational expressions.
Are they expressions that are rational?
They are. But not in the sense of like... so, this board is like super, like look at this. Oh. Thing happened. So if you have f of x is p of x over q of x, all right, where p of x and q of x are polynomials, then that makes this what is called a rational function. So rational functions are like formulas, are functions whose formulas are built from fractions of polynomials, all right? And you can also have like sums of these things, all right? We'd still count it as a rational. So that's sort of like a standard form, but you'll see that we can have other patterns. So let's just look at one here. Example 1. So if we had f of x 1 over, let's say, x minus 1 plus 1 over, say, x plus 10, this would be also an example of a rational function. So the first thing we ask about a rational function that's a little bit interesting is what's its domain? What's the domain of this rational? Or you could say, what's the domain of this rational expression? Can you guys tell me? Yeah, we need x not equal to 1 or minus 10, right? So can we express that in interval notation? You're like, oh yes, please, I love interval notation. So I hear my audience, I hear what you're asking for, and I will help. So minus infinity to minus 10, units minus 10 to 1. Do any of you guys know who Matt Walsh is? Just curious. Matt Walsh. Do you know Matt Walsh?
The name sounds familiar.
If you know who Matt Walsh is and you like him at all, make sure you watch his piece on why he's dancing in Dancing with the Stars. It's beautiful. Well, yeah, Matt Walsh is on Dancing with the Stars. You don't know this? You're like, I don't watch TV. I'm a college student, right? You're saying he's the actor from Veep? Apparently there's some show called Veep. I don't see it. I haven't really watched it. Anyway, so in interval notation, you take all the real numbers and you've got to delete minus 10 and delete 1. This is how you do it with interval notation. All right? So there you go. That's the domain for this expression. Let's look at another one. This one will be easier. F of x equals to 3x minus 1 over x squared plus 1. What's the domain of this rational expression? So the question is this, right? Is x squared plus 1 equals to 0? For any x. Well, yeah, But those are complex numbers, right? Like plus or minus I is the solution to that, yeah? Because I get x squared equals to minus 1, which gives me x is plus or minus the square root of minus 1, also known as plus or minus I, right? So, irrelevant. Irrelevant. I can't spell. Anyway, irrelevant. Because we only consider, our backdrop here is to consider functions of a real variable. Okay, so if there's some complex number that messes up the formula, we don't care. So what's the domain then for this rational expression?
1/3?
What's that?
1/3?
1/3. Now you're talking about 1/3 because that's what makes the denominator 0, the numerator 0. That's fine. That just means that the function's 0. That's allowed. So we don't have to throw that out. So, in other words, we don't have to throw anything out. Here the domain is just all real numbers. It's just minus infinity to infinity. That's the domain in this case. Everything.
Bless you.
How'd you get that?
If there's no trouble, then the domain is all real numbers.
No trouble, what do you mean by that?
What is the trouble? The trouble is division by 0.
Okay.
That's the only trouble for us right now. We could also think about taking the square root of a negative number. That would be troublesome as well. At the end of the course, we'll talk about taking a log of something. That's also something we have to watch out for negative inputs. But when we're thinking about the domain of an expression in here, there are 3 things we have to think about for the whole course. The one is division by 0. The other is like the square root of a negative quantity. And the third is the input of the log being negative. So at the moment, we're just worrying about division by 0, which was happening here from 1 and minus 10. But x squared plus 1 is never 0, so no trouble. Let's look at one that's a little bit more conniving. F of x equal to 2x plus 7 divided by x squared minus 10x plus 11. Maybe make that a minus 11 would be a friendlier thing to do. So minus 11. So you guys tell me, what's the domain of this one?
So we factor the...
Is everyone who's missing, have they dropped the class? Was my test that bad?
Yeah.
Yes.
Man. Just like I planned. All right, no. I'm just kidding. It's pretty much the same test I always give. But anyway, all right, so then what? Can we do, is the denominator 0? Well, what we should do is we should factor, right? So this is 2x plus 7, x minus 11 times x plus 1, right? So what is the domain in this case?
X not equal to 11 or minus 1.
Yeah, we need x not equal to 11 or minus 1. So in the interval notation, the domain is minus infinity to minus 1, union minus 1 to 11, union 11 to infinity. If you don't like interval notation like that, you could also write it like this: x such that x is not equal to 11 or minus 1. So the top thing I wrote is so-called interval notation. The last answer I gave is so-called roster notation. So sometimes I might say, leave your answer either in interval notation or roster notation. So this, if you're wondering, is roster notation. Yes, sir?
Does the numerator matter?
The numerator does not matter at the moment. No, not at all. Good question. It will matter eventually when we ask different questions. But as far as the domain is concerned, nah, not a factor. So we're now moving on to the problem of simplifying rational expressions. Now, technically speaking, we're covering an R section, which means review, which means allegedly you guys had this in a previous course. Just like allegedly you were taught factoring in a previous course, right? But you forgot, and that's okay. Like most people, that's the struggle in here. learning factoring. That's the big thing. And once you get that, well, pretty much you'll have the course. So if you're not confident on factoring yet, you need to seek out more problems to do on those. I certainly haven't assigned enough for you to become a master of it, if you weren't already. Let's see here. So here's one. So we'll just kind of attack it. We have 8x squared plus 16x. Actually, I did this one in the last section. It's too boring. Sorry, guys. Moving on to the next one. 36y squared. I need some variety in my life. Plus 72y divided by 9y squared. All right, it's pretty much the same. This is problem number 22 in section R7, if you're wondering. All right, so. Goodness. So just a general comment. Whenever we have a fraction of the form like a plus b over c, we can write that again as a over c plus b over c. So there's one of them, their laws of algebra for you. Something to look for. So we can use that here. We have 36y squared over 9y squared plus 72y over 9y squared. Has everybody already got the example 3 either written or photographed as appropriate? By the way, I am totally fine with you guys taking pictures, just to be clear. Like, it does not bother me. So I just want to erase this, if that's okay. Yeah. Just the boring part. You're like, you'll have to be more specific. But how about this? There are two things we can do. X to the m over x to the n is x to the m minus n. That's one thing we can do. But another thing we can do is if I have like x to the a over x to the b, I can simplify that also as 1 over x to the b minus a. So these are just a couple of simplifications we should keep in mind as we're working on things today, all right? So can we use those over here? What's 36 over, I guess, fine. I'll eventually get these out of my system. The other thing to keep in mind, guys, is if I have AB over CD, guess what? That's equal to A over C times B over D. So we can think about a fraction of two products as the product of the two fractions, like that. But what that really logically means is you can cancel as appropriate. Well, anyway, so here, how does it simplify? What's 36 over 9? 4. What's y squared over y squared? 1, right? Those cancel out, right? So I usually do something like, all right. What's 72 over 9?
8.
Yep, 8. And what's y over y squared? So, okay, so yeah, we could write, there are two different answers here. We could write 4 plus 8 over y, or we could equally logically write 4 plus 8y to the minus 1. But I usually like to write things with positive exponents as a general default. So I tend towards the first answer as the better answer. Because just as a general point of order, I usually aim for positive exponents. Y to the minus 1, that's an example of a negative exponent, right? Bless you, I guess. Let's see here. Another example. Here's one. Example, oh man, how did I go back to example 1? That was not example 1. That was 4. Phew, man, I'm shortchanging myself. Example 5. Yep. That is it for us here. Here's one. If I have 3 times 3 minus x over x plus 5, all right, times x minus 3, how can I simplify this?
Cancel out the x minus 3, well, 3 minus x and then the x minus 3.
Now you say cancel out the what?
The 3 minus x and the x minus 3.
So let me make a step here. This is equal to minus 3 times x minus 3. Do we agree? Does everyone agree we can factor the minus out like that? Think about it. If we multiply that back through, we get a minus 3x and a plus 9. Just like if I multiply this out, what do I get? 9 minus 3x, right? So, I mean, that's ultimately the judge. If when you multiply the numerator out, you get 9 minus 3x, well, this also gives us minus 3x plus 9, right? So that shows you that that is a legit factoring. The judge of any factoring step is, does it multiply out? It does. Yay. Now what? Cancel the x minus 3's. Woohoo! And we're left with minus 3 over x plus 5. Now when is that true? That's only true if x is not equal to what? X is not equal to negative 5. So this is actually for x not equal to minus 5 and also 3. That's the interesting thing about rational expressions. Simplifying a rational expression can change its domain. Do you see that? Notice this. The domain of what we started with does not include minus 5 and 3, right? But by making this simplification, we have an expression which just has trouble at minus 5 but not at 3. So simplification steps for rational expressions can change the domain. It's just something to watch out for. That's not a bad thing, it's just how it is. But it is one of the things we have to think about as we go on. It'll become more of an issue when we get to graphing. Let's go on. So next up, we should talk about a more interesting simplification problem. Example 6. What if we're up against, let's say, x squared minus 4x plus 4 divided by x squared plus x minus 6. How can we simplify that? Can you factor it?
Yes.
What do we got? I think we've got x minus 2 times x minus 2. And then the denominator, we have what? We've got... so what can we do? And we get x minus 2 over x plus 3. Yay. Simplified. All right, example 7. Let us take a gander at, let's see here, where is that one? There's one in here I like. Let's see here. 3, oh, where'd that thing gone to? I just saw it, now I lost it. It doesn't seem interesting at first, but it's kind of interesting. 7x plus 8 over 3x plus 2 minus x plus 4 over 3x plus 2. So when I first saw this problem last section and I worked it out like an hour ago, I was like, this is boring, because like the next example we'll do will be something like this. 3x over x minus 1 plus, x plus 2 over, say, x plus 3. That will be our next example, okay? Fine. But this one is annoying because it has what? It has different denominators, right?
You gonna make it the same denominator?
Well, yeah, we will in example 8. But example 7, it's already the same denominator, right? So what does that mean? Woohoo! Oh, I'm sorry, I'm using this hideous Carolina blue. My apologies. So we have 7x plus 8 minus parentheses x plus 4. Now, I put that like that because I want to emphasize that that minus has to go to both terms. We have to distribute the minus. That is by far the most popular mistake here to make. So I have 7x plus 8 minus x minus 4, all divided by 3x plus 2. Does that simplify? 7 minus x is 6x. 8 minus 4 is 4. Can you guys factor out of 2? Okay, so factor out of 2 of the numerator. My bad, that was a 3x plus 2, right? And then there's 3x plus 2. Wait a minute. What happened? Look at that. Yeah, these cancel those out, and we're left with 2. Yeah. Which I think is kind of amusing, right? Because if you look at this, does this look like 2 to you? It doesn't look like 2 to me. But there it is 2. Now, before I do this, I need to just take a walk down memory lane with you guys for a second here. And quick question, what's 1/3 plus 1/5?
1/8. Oh no, you gotta do that silly thing.
Yeah, that silly thing. What do? We do 1/3 times 5 over 5 plus 1/5 times 3 over 3, right? So that's 5 plus 3 over 15. So 8/15 apparently. So when we have to add fractions, we have to make a common denominator, right? And a good way to do that is to multiply by 1. Now you probably were taught to cross multiply or something. That's an equivalent idea. I see some no, not taught to cross multiply? No? Just use calculator?
Yeah.
Oh, see, this is why you guys can't factor. If you've always, I'm not kidding. Like if you always use a calculator, you've not developed the number sense. You don't have ready at your mind's, bend. You don't have all of the arithmetic facts about small numbers multiplying without using a calculator. It slows you guys down so much. What's that? If you could be bitten by a radioactive number?
Yeah, give me number sense.
I like that. Be bitten by a radioactive number to give you number sense. Bonus point. Send me an email about that, please. That's an amazing comment. That is definitely bonus worthy. Let's see here. So 3x over x minus 1. So I take this first part and I'm going to multiply it by x plus 3 over x plus 3. That's like this. Then I take my x plus 2 over x plus 3 and I multiply it by a different one. I multiply it by x minus 1 over x minus 1. So I'm just multiplying by 1 in a strategic way to make them have the same denominator, see? So then I have 3x times x plus 3 plus parentheses x plus 2 times x minus 1, all divided by x minus 1 times x plus 3. All right, and then what? Well, then we try to clean things up. So we've got ourselves a 3x squared plus 9x plus x squared plus 2x minus x. I'm just foiling it out, guys. Minus 2. Now, I just made this problem up, so it really shouldn't simplify nicely, okay? If this simplifies nicely, it would be like an amazing accident. How many x squareds do I have? 3 here, 1 there, so 4 total x squareds. How many x's do I have? 9 plus 2 is 11. 11 minus 1, 10, plus 10x. And the constants are minus 2 divided by x minus 1 times x plus 3. Can you guys, I mean, I guess if you want, we could factor a 2 out of the numerator. I guess we could do that, right? That's not too much work. So 2 times 2x squared plus 5x minus 1 divided by x minus 1 times x plus 3. I don't think we can stick a fork in it, it's done. I mean, that quadratic does not factor nicely. You're like, no, that's kind of, well, this is the R7 section, so we don't know about completing the square in this section. And as a matter of custom, I usually don't do the completing the square business here so much. Admittedly, there are places where that would be important. But my focus is, yeah, that's it for that one. Let's do another one. You guys ready? Ooh, I shouldn't have erased what I just erased. Oh well. What happened?
I was just wondering, because I figured it out then. Because, like, I was wondering if you could have just crossed out the x minus 1 in the beginning, but you're adding.
Oh, yeah. Yeah, I have to have the fractions have to match up. We have to make it.
In the equal to 3x times x plus 3 plus x.
Oh, why can't I just cancel these x's?
No, in the 3x plus x plus 3 plus x plus 2 plus times x minus 1. Yeah. I thought, I was like, why can't you just cross out the x minus 1's negative, but you're adding?
Right, that's a very good question, and it was brought up in the last section as well. It's like an important question to like wrestle with that question. Why can't we cancel this x minus 1 with this x minus 1? The reason is that there's not also an x minus 1 over here. So like, just to follow up, example 9, if I had, x squared times x minus 1 plus, x minus 3 times x minus 1, all divided by, x plus 2 times x minus 1. In that case, see, I could make the following algebra step. I could factor x minus 1 out, and that would leave me with x squared plus x minus 3 divided by x. I'll write the x minus 1 first for my purposes. They commute, right? And then, because it's on both and I can factor it out, then I could reduce it. Then I could cancel these, and I have this. I don't think that factors nicely. Yeah, so that would be it for now. What's that? Ah, okay. But that's a great question. That's a really good question. Because if we could cancel like that, everything here would become like way, way easier. Because you could always just like cancel x's all over the place. But we unfortunately it's not like that. Okay, here's an oh man, I thought I was past it. Here we go. Next example. Let's try our hand at x squared plus 2x minus 15 divided by x squared plus 11x plus 30. All right, and just for giggles, I'll say divide that by x squared minus 8x plus 15 divided by x squared plus 2x minus 24. Now, that's the last time you'll see me write that divide symbol. I pretty much never write that because it offends me. Yep.
For the last example, can't you factor the one on the numerator, just x plus 2, x minus 1?
But that's what I was thinking for a second. But multiply. What do you got? 2 times minus 1, you get minus 2, not minus 3. Yeah. I mean, you forced me to it. X squared plus x minus 3 is x plus 1/2 squared minus 1/4 minus 3, also known as x plus 1/2 squared. 3 is 12 minus 13 over 4. So here's how it factors. And that's why we didn't do it, because blah. So we're not doing that. What you were thinking is what I was thinking, though. And then I was like, the 3. Curses. All right, anyway. So, divides. This notation is in your book. I won't put this on the test. I don't use this notation. This notation is not used in higher math, pretty much. So instead, what we like to write is a compound fraction. And the way that works is it's a fraction of fractions. So plus 2x minus 15 divided by x squared plus 11x plus 30. And then you divide that by x squared minus 8x plus 15 divided by x squared plus 2x minus 24. Now let me confess to you how this actually works. Before we do any kind of algebra or anything, let me just tell you how this works. So like the algebra here, can I erase my evil factoring over there? So let me erase the evil factoring. Evil? Oh, don't breathe that stuff. It's not good. All right, so here's the deal. If I have A over B over C over D, the way this simplifies is A times D over B times C. Now let me, middle step. This simplifies as A over B times C over D. Excuse me, I'll get it eventually. D over C. In other words, AD over BC. So like that's how we do fractions of fractions. We don't actually divide, we multiply by the reciprocal. Multiply by the reciprocal. So let's do that. Multiply by the reciprocal. X squared plus 2x minus 15 over, man, I should have found something that wasn't so lengthy to write this all out. Sorry I'm introducing this concept with such a hideous expression, but here it is. So what's the reciprocal of the denominator? We flip it. So it would be x squared plus 2x minus 24 divided by x squared plus minus 8x. I regret my decision to change this to a division problem. This is a multiplication problem in the book. I flipped it. That was a bad choice. All right, now that I fixed it. So this division problem is actually, the way to look at it is just multiplication by the reciprocal. The reciprocal is just flip the fraction. All right, let's factor. So here we go. X plus 5, x minus 3. That's the first one. Then this guy right here is x plus 6 x minus 4 it was a good marker, but now it's dead.
The green one you just used?
Yeah, it's
That
dead.
is not dead.
We can go fish it out if you want.
I'm not going to, but that's not dead.
It's dead. It's dead. Totally dead. This one here, x plus 5 times x plus 6. See, if I was using chalk, we couldn't have this debate, you know? All right, so x what? X minus 3, x minus 5. Check this out. This one problem has got not 1, not 2, not 3, 4 factoring problems. And that is why you got to know factoring. Also, it's also why if you just work on the homework that is now assigned and you take the time to appreciate what's going on, you can learn factoring as you go on in the course. You don't necessarily have to drop everything and go back to the early material. If you try to fix your factoring mistakes as you're going here, then you can get better. Because there's just factoring. It's always with us. Anything cancel?
Yes.
The
This starts with x minus 4 over x minus 5.
x minus 4 over x minus 5. Hooray! Excellent. So I think I have 2 more examples for today. I don't know if I somehow never have. Well, we ended 405, right? Okay, we're fine. We're fine.
Actually, we end at 4 o'clock.
Yeah, I thought it was at 4.
Well, I better hurry then. Let's see here. So, example. Did you move me? Thank you. Example 11. What if we're up against 100 x squared y over 8 x y cubed times, I don't know, 4 x y squared over, I don't know, 5 x to the 4th y. So there are different strategies for doing this. Here's one very boring strategy. Simply multiply everything out on the top, multiply everything out on the bottom. All right? I'll do it this way. So what's 100 times 4 is what? 400. X squared times x is what? X cubed. Y times y squared, y cubed. Downstairs, 8 times 5 is 40. X times x to the 4th is x to the 5th. And y cubed times y is y to the 4th. All right. Now we can simplify that. What's 400 over 40? So 10. And then we have what? If I keep positive exponents, what do I have? I have 10. Looks like we're going to have the denominator wins both times, right? So x to the 5 minus 3, which is x squared like you said, and 4 minus 3. So the answer here is 10 over x squared y. All right. So final example for today. Example 12. It's another compound fraction kind of problem.
Wait, don't. I'm like writing down my thoughts.
All right, I'll stop.
What are we doing?
Hmm? If what? What? If what?
Because if that's just one number, then like what if you have like 100x squared y plus?
Oh, if there's pluses, then that's a different matter. This only works if you just have multiplication of things without sums. If you have things with sums, then you got to like try to factor out common things. And
I already started on that.
I have an example that kind of answers your question, if I can find it. Like example, there will be. Sorry, now there will be two final examples, but it was a good. It's for a good cause. Example 12. I lost it again. Y cubed plus y squared over 7 times 49 over y to the 4th plus y cubed. I mean, that's kind of like what you're talking about, right? And so something like this, what I do is I factor out what I can. Downstairs I've got a 7. I can factor out a y cubed down there. Y plus 1. See, and then once I've done that, I can cancel. And 49 over 7 is 7, so I get 7y squared over y cubed, which of course then is 7 over y. Which, you know, I would point out that like the problem that we started with there sure does not look like just 7 over y, right? I mean, I think it's an interesting simplification. Final example for today, example 13. I'll make it relatively simple. What if we have 3 plus 1 over x squared over 2 minus 1 over x squared? How do you simplify this kind of compound fraction? What should you do?
I want to say just like multiply them simple, but it is simple.
Well, yeah, you could do that, but there's an easier way here. So the given problem's in purple. What I'm doing to manipulate it is in red. What I do is I multiply the top and the bottom by x squared to clear out the fractions. So I've multiplied by x squared, multiplied by x squared. That gives me 3x squared plus 1 divided by 2x squared minus 1. And there you go. Simple as that.
That's what I was trying to say.
Oh, okay, good. Well, then you got it. Now, guys, I should have the solution for the test posted soon, but I'm going to give it back to you now. So.